Okay, so as you're preparing for your test, for the multiple choice part, I want you to remember that you must estimate, and you should expect easy math. So when you're given numbers like 76, you make it 75. When you're given a number like 48, you make it 50 and use that 50 in your calculation. 0.25, get it out of decimal form, think about it as a fourth or a quarter. Never ever forget that percent is always part of a whole times 100. So if you are given 34%, you know it's 0.34, and you know that 0.33 is 1/3 of whatever you have. So just kind of think in those terms, but bigger picture, don't get lost in the minutia. But straight up, there are some numbers you're just going to have to do straight up. They're easy. They're to be straight, be division, and you should be able to tell by approximation. That's a really big, important issue, is approximate. So you're going to use the whole numbers. You're going to get close to your approximation and go with it. By and large, the choices that you have are separated far enough from each other, the values are separated far enough from each other, that you can easily pick out an answer from the approximation. If you can't, then just fall out and do the math. All of it, or do the complete portion. But you should be able to do that. And typically, your numbers, if you're given a set of measurements that are numbers for the same thing, they typically go least to greatest. That'll help you dig around for the answer. So you have to work the problem and go back and find your answer. Don't forget that. You're fully expected to do math. There's no eyeballing it. Let's put it that way. All right, never forget that formulas are ratios. And so that when we were looking for the empirical formula, which is the lowest whole ratio of whole number ratio of the atoms in a molecule, well then we divide by small as a part of that. And so that's always how we get a ratio, because whatever your small is becomes the 1, because when you divide the smallest by itself, you get a 1. That way, we have some grounds for comparison. So I wanted to work one problem with you, just kind of show you this, because it's a little bit different. Most of the multiple choice questions that we worked on were about solutions. And so that is not the major component of your multiple choice test you're having tomorrow. It's about formulas, empirical formulas, calculating masses, moles, from reactions. So let's look at this problem. In which of the following compounds is the mass ratio? Oh yeah, by the way, a lot of these are old, well, they're all released items, but atomic weight is the same thing as mass. Weight replaces mass. Those are used interchangeably. They finally just quit using weight 10 years ago or so, and they went using mass for everything. But so don't be alarmed when you see the atomic weight is blah blah blah. Just know that they mean atomic mass. Okay, so the mass ratio of chromium to oxygen, so it's going to be in that order. Chromium to oxygen is closest to 1.62, 1.62, put in the order they give you, to 1. In which of the following formulas? I don't know. Well, what am I going to do? I've got a periodic table, and I know that the mass ratio, that's what they're talking about, the mass ratio. So I know that I can go to the periodic table, and I can know that there are 52 grams per mole in chromium and 16 grams per mole in oxygen. All right, now, okay, so these formulas, it's going to be some mass ratio, and so I can get that by looking at those subscripts. All right, so 52 looks like an ugly number to me, so I'm going to make it a 50, and I'm going to make 16 a 15 because I can do 15s in my head and I can do 50s in my head. And so literally I have to take these ratios and figure it out if, in fact, if the formula is CrO3, then what's this going to look like? Cr to O, and then this is going to be 3 of these, right? CrO3. So I'm going to have, if I call my O, I'm calling it 15, so that's 3 of them. Chromium, I have 1 of it, and I'm calling it 50. That's a 15. So this is going to look like a mass ratio, or the masses at 45, because 15 times 3 is 45. So if I need the ratio, which I do, divide by small, 45. Got to do both. This is 1. Somebody becomes 1. This is 1 something. I don't need to figure that out now. I just need to know it's 1 something, so this is in the ballpark. If I go to, let's say let's drop down and go look at C. For choice C, it is CrO. Well, that is going to be 100, not 100, silly, 50. So my Cr is 50 to oxygen 15, and there's 1 of them. So if I'm looking at the ratio, 15, this is going to be my 1, 15, this is going to be 3 something. So this is not in the ballpark because the mass ratio is 3 times as much. This shows 3 times as much chromium as oxygen. So this is incorrect. So I can wipe C out. If I go look at Cr2O, well, then that means I've got 2 chromiums, so that's 2 at the 50, so that's 100, to 1 oxygen that we said was 15, and I can't write that far over. I don't know what happened here. So that's 100 to 15. Well, that's 1, and then 100 divided by 15 is a whole lot more than 1. It's like 5, 6 plus. So we know that this is 100 to 15 is a whole lot more than 1.62. So here is another way you think about it. 1.62, it's greater than 1.5, but less than 2. So it's greater than 1.5, less than 2. This is way more than 2 times the mass of chromium for the mass of oxygen. Therefore, that's out. So Cr2 is out. And then we can look at E. So Cr2, I'm going to do it over here, O3. So that's going to be 2 chromiums. So each at 50, that's 100. Oxygen 3, each at 15, so that's 45. If I wanted to do all this out, and I did by 45, I'm 2 plus something. So 2 times the mass of chromium per mass of oxygen, if this were the formula. So that is incorrect. So now I'll go back and I'm going to do B. Oops, I didn't mean to do that. So undo, and undo, and here. So we only had 1 contender, and that's A. So let's go look at B. So CrO2, so chromium is 50. 2 of the oxygens, each at 15. That's going to give me 30. That's 50. So 30 divided by small, that gives me a 1. Got to do it to the other side. So this is going to be 1. 30 goes into 50. 1 something. So do I know what? No, but I can go find out. So because I've got 2 contenders, and I like 30 better than I do 45, so I'm going to do this, and I'm going to say 30, and that is a 1, and I'm going to get 30, and I'm going to have 20. That 1 doesn't go there, it goes here, sorry. And then I'm going to bring down I'm going to get a 0. So 3 goes into 200. 3 goes into 26. 1.6, I've found the magic number. I don't have to go any further than that. This one's not going to be 1.6, but if you want me to prove it to you, 45 into 50 goes 1 time. have 5 left over. So 45 goes into 50 one time. So that is wrong. And, and then B is going to be, so this is not it, and B is going to be your choice. Okay, so did I have to go through all those? No, if I'd have gone in order, you can just put some logic to it. If you simplify these numbers, you may be able to just look at them and tell, like 100 to 15, bam, and not have to, you don't have to write all this stuff out. Please, Lord, no, you don't have to write all this stuff out. I'm showing you how to do this and just showing you on the paper how to do it. But in your head, you literally could have said, once you got to this point, once you got to here, and you're thinking, I need more than 1.5 but less than 2 times the mass of chromium as I have oxygen. So, or half again as much is another way to think about it. Half again as much, isn't that right? A little more than half again as much. That's a better way, much better way to say it than what I did say. So, if you're just thinking about it in those terms, and I just erase all this jibber jabber, you could just think like this is going to be 50 to 45, 50 to 30. So what am I looking for? 1.5 as much again. So it looks like that's a contender. That's not a half as much again. 50 isn't half as much again as 45. That way you could eliminate it easily. This is going to be a 50 to 15, so that's definitely out. This is going to be 100 to 15, that's out. This is going to be 100 to 45, that's out, and there's your answer. Okay, so as you're working these, just don't lose sight of that fact. And if you're given a 0.24 something, think a quarter. 0.24 is really close to 0.25. Okay, so I hope this helps, and please, whatever you do, do not write all this stuff to figure out this thing. It wasn't necessary. If it makes you feel better about doing it, it's not necessary though. Nobody's checking anything except your bubble. Okay, so you don't have to show any work. You don't have to prove it. You just have to figure it out. Okay, and I hope this helps.